Now let's talk about how to write expressions for the electric and magnetic fields. We started with the expression in the frequency domain, where we had the electric field going in the z direction. So here's the direction of propagation, and here is the polarization, or the direction that our vector of the electric field is in. We have an EX0 plus, we have attenuation, we have a phase change, and then we have the reflected wave. So this is a wave that's traveling in the positive direction. This is a wave that's traveling in the negative direction. If we wanted to write the time domain form of that, we would have Ex of z is the magnitude times cosine of omega t, and take this term right here, minus beta z times this term, which changes the magnitude. On this side, it's going to be plus Ex0 minus, that's the reflected field, cosine of omega t plus j beta z plus multiplied by e to the plus alpha z. Now let's emphasize again the direction of propagation and the polarization of this vector. So here is the x direction, y direction, and z direction. If I plotted the direction of propagation, I've got a wave that's propagating in the z direction. That would be this term right here, Ex0 plus, and it has this phase term. This x right here is telling me where the electric field vector lies. So here is my electric field vector. It is in the x direction. We say that this is an x-polarized electric field traveling in the z direction. Now if we analyze this term right here, the reflected field, again we have our x, y, and z. This is going in the negative z direction. So this is a wave that is traveling in the negative z direction, but it is still x-polarized. Here is our electric field polarized in the x direction. The polarity tells us where the electric field vector lies. That's the same thing as saying we used a dipole antenna oriented along the x-axis in order to produce the electric field. It means this electric field can also be picked up by a dipole antenna along the x-axis. It means that the wave is traveling away from this antenna in the z direction or away from the antenna in this negative z direction.